So this video is going to show you how to develop the bevels for the semi-octagonal roof using the geometric method. So again, you can see I've drawn out a center line plan view of the roof and the section, and we have the key features we need: the half span, which is also the same distance back to a gathering point, and the rise. Remember, with this particular plan, doesn't particularly matter what proportions your plan's drawn to. The main thing that matters is that the pitch is the correct pitch for your roof, and if you get the pitch right, then this set of bevels will work for any octagonal roof at the same pitch. So we've got those. So as per usual, the first two are the easy ones. Once we develop our section, straight away we get our plumb and level bevel for our common rafter. So they're done nice and easy. To work out the edge bevel creeper, again, what we've done in the past is we've drawn in here a creeper member coming onto the rafter, but because this is going to be a fairly small distance, I'll do this one full size. So instead of drawing in a creeper, I'm just going to use my centering rafter as my line, and we'll use this as our level line distance. So we develop that up the ridge line to there, come up here at 90 degrees to our true length, same distance as here, extend that through to the apex, and that gives us bevel 3, which is our edge bevel for our creeper. Okay, now this is the next one, the edge bevel for the common rafter. This is the bevel that's different to a standard hip roof. So what I'm going to do, I'm going to pick a rafter down here. So I'll use this rafter. I'm going to come 90 degrees off that rafter at the rise. So this distance here. Come 90 degrees off there, that distance. So 90 degrees off here, that distance. Join that back to the plate. And that gives us, again, bevels 1 and 2. Because we've basically just recreated this triangle down here. But that lets us now develop the edge bevel. So what we do is we draw a line from the plan length of the rafter at 90 degrees through to the centering rafter, and then we extend that up to the true length side of the triangle, come 90 degrees off there, the same length as this line, and then join that back up to the point here, and that will give us the edge bevel for our common rafter. So make sure you don't get those confused. We've got edge bevel creeper is 3, and edge bevel common rafter is 4. We then have to do our hip bevels. So we're going to pick a hip. So I've got a hip over here, and we come up off the hip our rise at 90 degrees. Join that back to there, and that'll give us plumb and level bevel for our hip. And then we need to do the edge bevel, so I'll get rid of that stuff. So edge bevel hip. What we're going to do, we're going to draw a line at 90 degrees from the plan length of the hip up till we hit the true length of the hip. They're going to take this distance here and transfer that up at 90 degrees to the true length of the hip, that distance, so they're equal. And join that back up to there, and that gives us the edge bevel for the hip. Remember, it's going to be a fairly steep angle or bevel this time because of the 45-degree corners. Face bevel purlin, as we've done in the past. Up here, we're going to draw a line at 90 degrees to the true length line, down till we hit the center of the center line of the section. We're going to develop that around using a compass. So we get a mark on the plan length, and then develop that point and that point down until we hit our first hip, which is this one here. Help draw a line horizontal across there, and then from this point we go back to our apex, and then that'll give us the face bevel purlin. An edge bevel, as per usual, it's just the opposite of our bevel, our creeper bevel. So our creeper bevel was number 3, so our edge bevel purlin is going to be number 9, just there. So there we go, there are all the 9 bevels developed geometrically for a semi-octagonal roof.